Give a hand to Professor Sven. Werner.
Thank you, Brian. I have to learn this also. Okay. So this is a presentation about two parts, two perspectives. The first perspective is about the situation in the world today and what we can learn from history. And the second is about the project performed within the district heating program within the International Agency Technology Collaboration Program on district heating. So we performed during 3 years. So that's a background for the presentation. And the first article, the international review, is actually reprinted in the book of abstract. You can read it there. You can also download it. I'll give you the link later. So that gives you the outline here, that we will look at the global heat deliveries. We will look at the heat and fuel supply today to current systems in the world. We look at the carbon dioxide emissions because depending on what kind of heat supply you use, you have different carbon dioxide emissions today in different countries. And then we can make some kind of conclusions concerning the current state of district heating in the world today. Then we change the perspective and go to the transformation roadmap perspective, and it's about, we could call it conceptual roadmap in order how to obtain the low temperatures we have to have in future system in order to be efficient. 4 generation systems had different features, but the low temperature is one of the most important features. And then we present our condensed transformation roadmap, and then we present some main conclusions here. So this is the global heat deliveries in the world. You see that it's 3 regions in the world that have considerable heat deliveries. It's Russia, China, and Europe. But then both in all 3 areas, there's a rather large proportion of industrial deliveries to industries, especially in China. Deliveries in USA is underestimated here because this is just the heat deliveries from the energy sector. But many of the district heating systems in USA is located in campus areas, and these are not belonging to the energy sector. So actually the heat deliveries in USA is above 1 exajoule. So it's 3 times higher than what's presented in the diagram. So it's actually the 3 main areas is Europe, Russia, and China. And the next picture was inspired from the last conference in Aalborg. I had a long discussion with Brian about what is the market share in the world. I guessed it was 8%, and he thought it was too high. So I had to convince him, and this is the picture that will convince him, that the world market share for district heating is about 8%. And in Europe it's about 12-13% for buildings. This is just for buildings. I don't include industries here. But that you see that's a very different proportions for different supply. But most importantly is here that actually electricity have higher proportions than district heating. So that's a challenge for the future. So district heating is small in the world. It's not a major player in the energy markets. It's just a few percent of the final consumption in the world is district heating, actually, because we also have cars and we have industries and electricity in the balance. So the next is to look at the heat supply in different regions. And we look just for the world and for European Union. This is the world. So you can see that a rather high proportion is actually heat recycling from CHP and industries. A very small proportion of the green areas, that's renewables, both in recycling and direct use. And it's a very high proportion of direct use of fossil fuels. And that's mostly natural gas in boilers in Russia and coal in boilers in China. So they don't fulfill the fundamental idea of district heating to have a heat recovery. That's the world situation. And it's somewhat different in Europe. So it's a lower proportion of direct use in boilers, and it's a higher proportion of heat recycling from CHP and industries, and the proportion of renewables is much higher. It's almost 30% the proportion of renewables today. So it's higher proportion than in the total European energy balance, since Europe is heading for 20% market share for renewables in 2020, but district heating has already reached that proportion. And the fuels behind it is that we have a large proportions of natural gas and coal, and that's the large consumption of gas in Russia, and coal is in China. So it's that's influencing the total fuel balance for district heating in the world. And the corresponding diagram for Europe is that a much higher proportions of mostly biomass as renewables. And the proportion of coal is decreasing all the time, and also now natural gas is decreasing also. So this is, of course, gives very different carbon dioxide emissions from the two areas, the world and the European Union. So then we have to look for it. So these are the development of the carbon dioxide emissions, calculated specific emissions as gram per heat delivered. And you see that's constant in the world because the reductions achieved in Europe is compensated by the increased coal use in China. So it's constant in the world, but it's actually decreasing in Europe, and the decrease is higher than the 20% that it's expected for Europe in the 2020 commitments. And the most important is the next picture, because there are all specific carbon dioxide emissions in the world for all 47 countries. There we have district heating sectors. It's 47 countries, and you see it's a very large variation. High emissions in China because the coal use, but in the lower end, you can see that Iceland is world champions in district heating, and it's decarbonized district heating because they use geothermal heat mainly. But the other two Nordic countries is Sweden and Norway that have low emissions. Of course, it's how you estimate the emissions here. In this case, I have allocated all the emissions for waste incineration to the waste sector, because then it follows the polluter pays principle. But you can make other allocations than I have done. But you see also that European Union has rather, in average, very low emissions, about half what you can get if you use natural gas. So you can see that the district heating sector in Europe is decarbonized to 50% about, compared to natural gas. So the conclusions we can have from this very, very short review about district heating in the world is that we have strong potentials to be viable heat and coal supply options in the future, but you have to lot of more work had to be done in order to achieve that. You do not get it for free. So it's you have to identify, assess, and also implement district heating systems in order to reach the global benefits of district heating. Okay, so if you're more interested in what this is, you can read the article in the book of abstracts. The second part is the transformation roadmap project. It was performed during 3 years with 5 partners, and the focus was in order, what kind of main steps should be taken in order to achieve very low temperatures. We wrote a definition article some years ago that we had a vision about 50 degrees to every customer and a return temperature of 20 degrees. And this is a very challenging vision, and no system hasn't yet been built with that features, so we have to all to contribute to achieve that somewhere. But in this project, we tried to identify the different situations. And first, we have to consider the 4 generations that we had, and we've also introduced in this definition paper. The first generation is more than 140 years ago. Then we started with district heating and steam. It was very high temperatures. And when the German engineers wanted to implement district heating in the 1920s, they preferred water instead of steam because it was become more efficient. And when the Scandinavian countries wanted to implement district heating in the 70s, they went for somewhat lower temperatures than the rest of the Europe used in the 70s and 80s. And that's the kind of system technology we have today. As